Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is correlation, which is part of our course called Research Methodology and Statistical Analysis. This is a course code of this particular course is MCO3. This is part of our program called MCOM, and we are here to discuss as far as this particular chapter 10 is concerned. We have in this unit around 4 important components, that is correlation, scatter diagram, regression and correlation. So we are here to talk more about this correlation. So correlation is a statistical method used to assess a possible linear association between two continuous variables. It is simple both to calculate and to interpret. So what we observe that when we are going to talk about, it is going to give the relationship between the two variables, and it is used for calculation as well as the interpreting the results thereof. So anyway, prior to going into the depth of this topic, I just want to recapitulate what exactly we have done in our preceding sessions. We have talked a lot about data collection. We have talked a lot about processing and preservation of data, which is considered to be the second block. And the topic which we are going to talk today is going to be cover in this particular block 2, that is correlation and regression. So gradually we are going to talk more about this correlation as well as the regression as well as the scatter diagram. So this processing of data we have already covered. We have seen how the data can be presented diagrammatically as well as graphically, and there are certain statistical derivatives which we have already talked about. Either it could be a ratio, rate or percentage, as well as we have elaborately covered the averages, how to calculate the average, either it could be mean, median, mode, or the variances which could be considered as a range, quartile deviation or interquartile range, or the standard deviation. So this part we have covered, and skewness is a very important aspect, because when you are going to talk about the shape of the data, I think at which direction the data is going to move, the skewness is very well explained in that. So taking into consideration, now the time had come where we have to talk more about how we are going to relate the data, how the two variables which are different in nature can be correlate. So this is the purpose behind that. And if we see that what exactly the review is, so when you are going to talk about the review examine the difference in the mean between groups, and how many independent variables are there and how many dependent variables are there. So if you see this particular image, you will find out that independent variables are one or more than one. So if it is one, how many groups are there, and if it is it could be 2 or more than 2, and for that and if it is more than one, in that case again the question is there. So there are differences or relationship is there, and when you are going to examine the difference between the groups, you are going for the t-test or ANOVA test. And when you are going to examine the relationship between two variables, I think correlation and regression analysis role is very important. So anyway, we are here to talk more about the preamble part of correlation, and once we acclimatize with correlation, then we will see how we can plot the scatter diagram, which is a very important way of plotting a diagram and getting the interpretation thereof. And then the correlation coefficient is there. So when you are going to talk about the correlation coefficient, either it could be Karl-Pearson correlation coefficient, or testing for the significance of correlation coefficient, or Spearman's rank correlation. So these are the points which we are going to cover. Then regression analysis, which could be covered at the later stage, and then what are the difference between the correlation and regression, which is a very important ingredient. So in this chapter we have 2 components, one is correlation, other is regression. And as far as this presentation is concerned, we will discuss about correlation only. Scatter diagram, correlation coefficient and regression we are going to discuss in the next presentation in a gradual manner, one by one. So if we are going to talk more about the correlation statistics, because we have already quoted that in our previous verdict, that correlation is a very important ingredient if you talk about the statistical analysis. The correlation between two variables is particularly helpful when investing in the financial markets, since this particular course, that is MCO3 Research Methodology and Statistical Analysis, is part of our postgraduate program called MCOM. So, and our Masters of Commerce students are more emphasizing on the financial market and how to, they can work as a navigator, they can work as a mentor. So, this statistical correlation is very important ingredient. So, for example, correlation can be helpful in determining how well a mutual fund performs relative to its benchmark, and other funds and asset class. And by adding a low or negative correlated mutual funds to an existing portfolio, the investors gain diversification benefits. And this is the beauty of correlation. So, in other words, we can say that investors can use negatively correlated assets or securities to hedge their portfolio and reduce market risk due to volatility or wild price fluctuations. So, this is the way by which the things are going to be done, and many investors has the price risk a portfolio which effectively reduces any capital gains or losses because they want the dividend income or yield from the stock or security. So, this is the model which is there, and correlation statistics also allows investors to determine when the correlation between two variables changes. So, this is a very important aspect because when there are change in the variables and what are the impact of all these variables, correlation role is very important. So, bank stocks typically have high positive correlation to interest rate since loans are often calculated based on market interest rates. If the stock price of a bank is falling while interest rates are rising, investors can glean that something askew. If the stock prices of similar bank in the sector are also rising, investors can conclude that declining bank stock is not due to interest rates. So, instead the poorly performing bank is likely dealing with an internal fundamental issues. So, what I mean to say that correlation statistics can be used in finance, and what are the trends of investing in the market. So, for example, a correlation coefficient could be calculated to determine the level of correlation between the price of a crude oil and the stock price of a oil producing company. So, since oil companies earn greater profit as oil prices rise, the correlation between the two variables is highly positive. So, these are the the relations which we are going to do, and now a lot of changes are coming up. How are the correlation used in business? Because since this particular course is related with the Master of Commerce student, so there is a great use of correlation in business. A correlation is fundamentally a comparison between two or more things, and when you are going to talk in terms of projection tool, the most valuable use of correlation is in predicting the future of a business direction. So, direction change, performance measures, data mining and patterns, all those things are going to have a great impact when you are going to correlate the things. So, correlation means association. So, this is the second way of interpreting the term called correlations. More precisely, it is a measure of extent to which two variables are related. Therefore, one variable increases as the other variable increases, or one variable decreases while the other decreases. So, an example of positive correlation would be height and weight. So, these are the things which are there, and if you see this particular image, you will find out that strong positive correlation is there. And if you see how it is going to be interpreted in terms of diagrammatical manner or the relationship manner, this is the way, like strong positive correlation is there. If we talk about the weak positive correlation, this could be the way of weak positive correlation. So, strong negative correlation. So, one is moving from left to right, other is, if you talk about the negative correlation, it is moving from right to left. So, lower part is right, and we are moving towards left way. So, weak negative correlation is depicted by this way, and moderate negative correlation it could be expressed by this way. So, no correlation, if you are talking about, it could be like this. So, when the movement correlation coefficient measures the degree of association, some say relationship between two variables, and the relationship between daily consumption of the fat, calories and body weight or attitudes towards smoking and heart attack risk. What is the relationship between student achievement and per hour study? This is all about the correlation. So, correlation is the relationship that exists between two or more variables, relationship between the heights and weights, relationship between the advertising expenditure and sales. So, correlation is sometimes termed as a covariation, because whatever the variation is going to occur, it is provide the relationship between them. So the method of correlation is also called coefficient of correlation, which we are going to elaborately cover in our next session in a more elaborative manner with the help of some good examples which can be under the ambit of coefficient correlation. So correlation analysis is a statistical technique used to measure the degree and direction of relationship between the variables. So this is a thing. So now the question is that can we use correlation to predict? Because there are certain FAQs, there are certain questions which are coming in the mind of a grassroots researchers or the statisticians that whether the correlation could be useful as far as the prediction is concerned. So correlation analysis provides information on the strength and direction of the linear relationship between two variables, while a simple linear regression analysis estimates parameter in a linear equation that can be used to predict value of one variable based on the other. So if we talk more examples of correlation, is there an association between children's IQ and parents' IQ, and degree of social trust and number of membership in voluntary association, urban growth and air quality violations, doctoral research funding and number of publications by PhD student, number of police patrol and number of crime, and grade on exam and time of exam. So these are the correlations, and the example which I have quoted is not confined to that only, and there are some good correlation is coming up. And if we see in the present end the way e-commerce is changing with the change of time, and now e-commerce is considered as a very omnipresent in nature, and we have seen that that lot of relationship is coming up with the consumers behavior towards the buying online or the other thing. So this correlation is also going to be occur in that. So correlation is the relationship between two variables, and the data can be represented by ordered pairs xy, where x is the independent or explanatory variable and is the dependent and y is the dependent or response variable. So what we are going to do once we find out the relationship between the two variables, and then we can start plotting a diagram or the graph. So scatter plot can be used to determine whether a linear correlation exists between the two variables or not. So if you see this particular image, you will find out that we have got two variables, and we have got 1 2 3 4 5 as far as x is concerned, and then you have got a values of y, which is in some is negative, some is positive, and some is 0. So -4. So now what we are doing, with the help of that, we have started plotting a scatter diagram, and we have seen that y, as far as the y variable is concerned, in front of -4 we have put one red mark, in front of -2 we have put one red mark. So now if you see, as far as x is concerned, x is 2 and 4 is y is -2. So there we have plotted. So this is the way by which we can plot the scatter diagram, and we will elaborately talk more about this scatter plot in the coming sessions, which full-fledged talks about what is the impact of scatter plot, what is the use of scatter plot, and what are certain utilities. So type of correlation either could be positive or negative. So one variable increases, that also increase positive correlations, and value ranges from 0.0 to 1. And the more you eat, the more weight you will gain. So this is one of the way of correlating the thing. So one variable increases, other also increases. So the more you eat, the more weight you will gain. So type of correlation is again called positive when one variable decreases, other also decreases. So it is considered to be a positive correlation. So value ranging from 0.0 to 1, and examples are the less you study, the lower your test score will be. So these are the examples by which we can say that there is a positive type of correlationship. And when you are going to talk about the negative correlation, so one variable increases, other decreases. It's called negative correlation. So value ranging from -1 to 0.00, and example are the older you are, the less flexible your body is. This is one of the example of negative correlation. So because one variable increases, other decreases. Now their correlation strength. So what value or we tell us, so weak or none is 0.0 to 0.2, and when you are talking about weak, it is 0.2 to 0.4, and when you are talking about moderate, it's 0.4 to 0.6, and when you are talking strong, it's 0.6 to 0.8, and when you are talking about very strong, it is 0.8 to 0.1. So how do we know that there is a significant relationship, or what are the results of value and significance. So a significance is quoted with alpha, which is considered to be 0.5, is a generally accepted conventional level in social science. This indicates that 95 times out of 100 we can be sure that there is a true or significant correlation between the two variables, and there is only 5% chance that the relationship does not true exist. So if p is less than 0.5, we can say that correlation between the two variables is significant. Now there are linear correlations. So these are the example of the linear correlations we have already talked about, that there is a negative linear correlation, there is a no correlation. If you see this particular image, it talks about negative linear correlation. As x increases, y tend to decrease. If you talk about no correlation, where you will find out that there is no such there is a lot of overlapping and there is no such relationship which is coming. And when you talk about positive linear correlation, as x increases, y tends to increase. And when you talk about non-linear correlation, you will see that how the graph is going to be plotted. So by comparing all these four graphs, it is quite clear that if there could be a correlation, it could be linear correlation, it could be of this kind. So there are certain advantages of correlation. It is simplest and attractive method of finding the nature of correlation between the two variables. This is very true, and it is non-mathematical method of studying correlation. And good part is that it is easy to understand. It is not affected by extreme items. It is the first step in finding out the relation between the two variables, and we can have a rough idea at a glance whether it is a positive correlation or negative correlation, because in our preceding slide we have seen that the figure itself, the scatter plot, the diagram which we used to plot, it's self-explanatory in nature, that what kind of relationship the dots have with one another. So but there are certain constraints. We cannot get the exact degree of correlation between the two variables. So when you are going to talk about the fact that two variables are strongly correlated, it implies cause and effect relationship between the variables. And if there is significant correlation between two variables, you should consider the following possibilities. And one is that, is there a direct cause and effect relationship between the variables? Does x cause y? Is there a reverse cause and effect relationship between the variables? Does y cause x? Is it possible that the relationship between the variables can be caused by third variables or by a combination of several other variables? Is it possible that the relationship between two variables may be coincidence? Now there are certain misconceptions which is small as well as somewhat insignificant, and it is important to point out that sometimes even a very low correlation may have clinical significance. For example, if we take an example of a two person like Ramesh and Rahim, had investigated over 5,000 medical patients to see whether stress might cause sickness, and patients were asked to tally a checklist of 43 live events. It was found that there was positive correlation of 0.118 between these two variables, and based on the findings, the Holmes-Rahe stress scale was developed and validated, which is considered as a 0.118, and now the clinical psychology or medical research, we must pay attention to even such small correlation. So what I mean to say that difference between the correlation and correlation coefficient is very important. And when you talk about the correlation is the process of studying the cause and effect relationship that exists between two variables. And when you are going to talk about correlation coefficient, it is the measure of the correlation that exists between two variables. So one is the process of studying the cause and effect relationship, and when you are going to talk about the correlation coefficient, this already exists between the two variables. So when you are in the process of studying the correlation, I think you will find out, is there any relationship between the two variables, and when correlation coefficient you start measuring it, it's give that there must be a relationship between two variables. So when should you not use a correlation? So correlation should not be used to study the relation between an initial measurement x and change in that measurement over time. And say yx or x will be correlated with yx due to the regression to the mean phenomena, and small correlation values do not necessarily indicate that two variables are unassociated. So why is correlation bad? Now the question is that the stronger the correlation, the more difficult it is to change one variable without changing another. it becomes difficult for the model to estimate the relationship between each independent variable and the dependent variable independently, because the independent variables tend to change in unison. So this is the thing, and when we are going to study more about correlation or coefficients or the regression analysis, because wherever and also we will have a comparison between the correlation and regression, and we will see that how this difference between the two is very important. Wherever we are not in a position to correlate the thing, then we start using the regression analysis, and this is the big difference between the two. And there are certain so I think we have elaborately talked about the correlations as a whole. And if we talk about the takeaways which we have extracted from the discussion, correlation coefficient are used to measure the strength of the relationship between two variables, and Pearson correlation is the most commonly used in statistics, and this measures the strength and direction of a linear relationship between two variables. So values always range from -1, that is strong negative relationship, and +1, a strong positive relationship. So values at or close to 0 imply weak or no linear relationship. So correlation coefficient values less than +0.08 or greater than -0.8 are not considered significant. I think we have a very elaborative sessions about correlation. This can give us a glimpse about what exactly the correlation is, and in our next session we are going to talk more about the plotting of the scatter diagram. Then we talk about the coefficient of correlations, and finally the regression is there. So after completing all this, we will accomplish this particular chapter. Thank you very much. Thank you.